On December 25, 2021, a European Ariane 5 rocket lifted off from the spaceport in French Guiana, carrying the most costly telescope ever constructed by humans. Following several postponements, the James Webb Space Telescope embarked on its space voyage. Little did anyone anticipate what would transpire just a few months later. James Webb has captivated, astounded, and challenged existing theories about the universe's origin and nature, raising profound questions for the field of natural science and humanity's future. Let's have a look and delve into this matter further. The James Webb Space Telescope had already become a significant challenge long before it soared into space, earning its reputation as the most expensive telescope ever built. A series of technical issues during its construction phase drove up costs, and the US Senate even contemplated terminating the project. However, the fate of the project had been out of the hands of the Americans and NASA for quite some time. Right from the beginning, this new space telescope was a collaborative effort involving NASA, the European Space Agency, ESA, and the Canadian Space Agency. They remained committed to the project, jointly bearing the additional costs that arose. On December 25, 2021, the telescope was launched aboard an Ariane rocket from Europe's Kourou spaceport in French Guiana. The choice of the powerful Ariane 5 rocket and the location of the launch site near the equator were ideal for efficiently sending an object as massive as James Webb to its destination at the second Lagrangian point, L2, over 1 billion kilometers from Earth. SpaceX had also proposed a rocket, but Elon Musk's Falcon Heavy couldn't match the capabilities required. ESA, being part of the collaboration, provided the launch vehicle and related services and, in return, will receive about 15% of the telescope's observing time. With a thrust of approximately 13,800 to 13,900 kilonewtons, the rocket lifted off at 12:20 p.m. local time. 3 minutes after liftoff, the rocket's first fairing was jettisoned. About 10 minutes later, James Webb was left attached only to the ESA upper stage. Following another phase of acceleration, the telescope separated completely. Floating in Earth orbit, James Webb gradually unfolded its solar panels, which had been designed to provide necessary streamlining and protection during launch. Engineers had designed all of the telescope's components, including the mirror and power supply, to fold away during launch. By the time the ESA upper stage engine shut down, the telescope had reached a speed of 9.90 kilometers per second. After separating from the rocket, James Webb was already decelerating and ready to deploy its solar panels. With the power supply operational, NASA performed an initial course correction. The full deployment was finalized on January 8, 2022. Currently, the telescope orbits at a speed of 727 kilometers per hour in a halo orbit around the outer Lagrangian point L2, situated about 1.5 million kilometers above the Earth's nighttime side. To put it in perspective, the Hubble Space Telescope orbits Earth at an altitude of only 547 kilometers. The choice of James Webb's location in deep space was intentional, aimed at minimizing atmospheric interference and the absorption of specific wavelengths of light that can occur when a telescope is in closer proximity to Earth. The launch of the James Webb Space Telescope promised a remarkable opportunity to delve even deeper into the universe's history, offering the potential to witness events shortly after the Big Bang. Scientists were eager to uncover insights into the formation and evolution of galaxies, stars, and planetary systems. Moreover, the mission aimed to observe elusive phenomena like dark matter and dark energy while searching for exoplanets. NASA dubbed this mission a journey to the dawn of the universe, a label that would prove to be quite misleading. Little did anyone know that this journey would challenge our fundamental understanding of the cosmos. The initial shockwave came with one of the first images released in the summer of 2022, shattering the hypothesis of the Big Bang. Instead of observing fewer and smaller galaxies as the telescope peered further back in time, James Webb uncovered massive galaxies that had already taken shape just 200 to 400 million years after the Big Bang. This revelation contradicted the prevailing theories about the universe's early days, which had predicted only fledgling star systems and the initial formations of stars. For nearly a century, the Big Bang theory had been considered nearly irrefutable, even though direct observations couldn't confirm it. The foundation of the Big Bang theory dates back to the work of the astronomer and former clergyman Georges Lemaitre. In 1927, Lemaitre proposed that the universe originated from a single point, evolving over approximately 13.8 billion years to reach its present state through a single cataclysmic event. Observations of galaxy motions and cosmic background radiation appeared to corroborate this view. It was widely believed that the universe would continue expanding into the future. The contributions of astronomer Edwin Hubble, after whom the Hubble Space Telescope is named, further solidified Lemaitre's ideas. Hubble's observations revealed that galaxies were moving away from each other, and the farther galaxies were moving at higher speeds. This led him to conclude that the universe, as Lemaitre envisioned, was indeed expanding. As objects in the cosmos appeared to be moving apart in a way that suggested they had once been closely connected, the Big Bang theory became the prevailing explanation. It described a universe that began with unimaginably hot, minuscule particles mixed with energy and light, which gradually cooled as they spread through space. These initial particles eventually transformed into atoms, stars, galaxies, and the planets we know today. Stars formed from the remnants of dust disks left behind by earlier stars, grouping together in stellar clusters. These clusters merged to create galaxies, and galaxies clustered into galaxy clusters. Various cosmic objects, including asteroids, comets, and black holes, also emerged during this cosmic journey. All of these processes unfolded over approximately 14 billion years. However, as scientists grapple with the newfound data from James Webb, they are faced with the sobering reality that something fundamental may be amiss with this long-standing theory. The evidence no longer aligns neatly with the existing model, requiring a re-evaluation of our understanding of the universe's origins. The awe-inspiring beauty of the initial images from the James Webb Space Telescope captivated the general public, but for scientists, these early snapshots posed serious challenges. Some scientists have attempted to find explanations, suggesting that the blurry points of light in these images might not be galaxies at all, but rather supermassive black holes. However, this leads to a different conundrum, as supermassive black holes should not have existed at this distance and during this time period. In their quest to reconcile these new findings with existing theories, some researchers have clung to the hope that there may be errors in the measurements of the galaxy's ages. Nonetheless, extensive validation using the most advanced and powerful telescopes worldwide has confirmed the accuracy of these age determinations. Yet, the scientific predicaments do not end here. One particularly perplexing issue is the apparent expansion of the universe, which may be an enigmatic optical illusion. The curious fact is that celestial objects like galaxies don't seem to shrink as their distance from us increases. In fact, beyond a certain point, they should appear larger and larger while their brightness diminishes. Paradoxically, the representation of galaxies in the James Webb Telescope's images exhibits indications of space that is not expanding, presenting a perplexing challenge to our current understanding. Another critical deviation from prevailing theories is the remarkably high density and orderliness of these newly discovered ancient galaxies. According to earlier assumptions, the first galaxies, formed through numerous collisions of smaller galaxies, should bear evident signs of these cataclysmic events. However, the James Webb Telescope unveils galaxies shaped as incredibly smooth disks and immaculate spiral patterns. These galaxies' appearances closely resemble those of modern galaxies. Astonishingly, the data suggests that during the so-called cosmic dawn, there were approximately 10 times as many of these pristine spiral galaxies as theory had predicted. This raises the fundamental question of how these immaculate and ancient galaxies came into being without the expected collisions. In light of these profound challenges to established cosmological theories, scientists now face the daunting task of reassessing the age of the universe itself, entertaining the possibility that it may be significantly older than previously believed, and reconsidering the very notion of the Big Bang itself. The discoveries made by the James Webb Space Telescope have thrown the door wide open to a profound reevaluation of our understanding of the cosmos. You might be wondering how scientists can extract so much information from seemingly blurry specks of light captured by the James Webb Space Telescope. It's a valid question, and the answer lies in the telescope's advanced technology and the way it observes the universe. The James Webb Telescope employs a set of specialized filters that allow it to capture images in the infrared region of the electromagnetic spectrum. This is crucial because it enables astronomers to detect the color of distant galaxies. In the realm of astronomy, color frequencies are indicative of various properties, particularly the age of stars within those galaxies. Stars exhibit different colors based on their temperatures. Cooler stars tend to appear yellow or red, while intensely hot stars emit a bluish hue. By analyzing the colors of stars within galaxies, astronomers can gauge their ages and other characteristics. For instance, on the deep field image captured by the James Webb Telescope, distant galaxies appear red, whereas nearby objects appear white or bluish. The filters on the telescope can isolate specific frequency and wave patterns from the collected light, providing insights into the size, luminosity, number of stars, and density of these galaxies. It's through these observations that astronomers can discern detailed information about celestial bodies and their compositions. The image in question was generated through a prolonged observation of a section of space that is relatively devoid of bright foreground objects. This unique circumstance allows the light rays from distant galaxies, due to the bending of space, to become visible. Such phenomena occur when objects far in the background are magnified, rendering them observable. This image, while capturing only a fraction of the universe, is a testament to the incredible capabilities of the James Webb Telescope. The telescope's improved sharpness and interpretive abilities surpass those of its predecessor, the Hubble telescope. In the future, astronomers will likely continue to capture images like this, potentially from different perspectives and time frames, to further explore the cosmos's mysteries. The quest to examine even earlier epochs in the universe's history will persist. Currently, the telescope's observational range extends back at least 13.5 billion years, just slightly short of the estimated age of the universe at 13.8 billion years. Researchers will strive to push the telescope's boundaries and gaze as far back in time as possible. If more galaxies continue to emerge that appear fully formed with rich star populations, it could challenge the prevailing Big Bang theory. The future of astrophysics holds the promise of unveiling even more secrets of our universe. As for the significant construction costs of the James Webb Telescope, which exceeded $10 billion, the scientific community and the general public will undoubtedly weigh the value of its discoveries against this investment. Science often progresses through ambitious and costly endeavors, and the knowledge gained from such missions can profoundly impact our understanding of the cosmos. We'll keep you posted. Thank you for your interest in watching. Tell us what you think about this discovery.